Hello, geometry students. Let's go through this review together before your test tomorrow. So you will have two main ideas for this test. The first is our block patterns. You are welcome to use the blocks on the test to create the shapes. But I will show you in this video how to go through doing that without the blocks. The next task is using your similarity ratios. So your zoom factor squared, and zoom factor cubed to build proportions so that you can find the remainder of the information. The last thing is kind of a combination of the two ideas with our 3D blocks and our area and surface area. We're going to be finding the area and the surface area and the volume of our three-dimensional figures. So we will work through those in this video. So the first page, standard 5.3, visualizing 2D and 3D formulas. We are going to create a map plan and assume that there are no hidden blocks in our shape. So here you can see we have 2 blocks deep and 3 blocks wide. So that means one row of this is going to be empty. One full row. Now, whether you make that the front row or the back row, totally up to you. I am going to do everything starting here at the front. So I am going to leave this one empty. Okay, so this will be empty. So I'm going to look here, and I have a stack of 2 blocks right here. And I have a stack of 3 blocks right behind it. That would be my son AJ accompanying me in the video here. Another 2 blocks and another 2 blocks. And then 1 block and 1 block. So now when I do my perspective views, if I'm looking at this from the front, you might notice that we see a maximum height here of 3 blocks.
3 blocks.
A maximum height here of 2 blocks.
2 blocks.
And a maximum height here of 1 block. So when I shade, I'm going to shade 3 blocks tall, 2 blocks tall,
2 blocks tall,
and 1 block tall.
and 1 block tall.
AJ is having too much fun with this. Okay? So yeah, you just kind of color that in. So it's kind of a stair shape. Okay?
Okay.
Okay. All right.
I have that.
So from the right, remember that back row is empty. So I'm not going to have anything here. There's only going to be 2 things. So on this side, this row, I have a maximum height of 2 blocks. The back row, I have a maximum height of 3 blocks, and that's this right here. So I only need 2 here,
2 here,
and 3
and 3
here.
and 3 here.
There's nothing in that third column because there is no third row. Lastly, for our top view, if I'm looking straight down on top of this, I have a 2x3 rectangle. So I'm just going to color in this 2x3 rectangle
2x2x3?
and leave that back row empty.
A 2x2x3 Rubik's Cube?
Yeah, my son loves Rubik's Cubes, and this is reminding him of that. Okay, so let's do one more. If you notice, this shape here is an L.
L.
So we
Yeah,
have
where's your side?
1, 2, 3 over and 1, 2, 3 down. So we have a 3 by 3 with this
A 3
empty
by
front
3.
corner. So we have this 2 by 2 region
2 by 2.
that is empty. So these are all zeros right
2
here.
by 2.
And then we have 1 block, 2 block,
2
and
block,
3
3
blocks. So 1, 2,
2,
3. And then down
4, 5,
that
6.
same pattern here. From the front, again, if I'm looking straight on, we have a maximum of 3, 2, 1,
3, 2, 1.
which is the same as this one, oddly enough. But our right
3,
view
2,
is totally
1.
different. So
3, 2,
3,
1.
2, 1.
1.
The right view, if I'm looking at it, we've got a stack of 3,
3,
a stack of 2,
2,
and a stack of 1.
1.
So we're
3,
going to
2,
invert
1.
that. 3,
2, 1.
2,
1.
1.
1.
From our map plan, everywhere we have a number other than 0
1.
is what we're going to shade in.
1.
So we have our 3, 2, 1, 2, 1, and then that empty corner. So now if I give you the views, can we create a map plan and figure out the volume of this? So here's what I want you to do. If I compare this, we have a height of 3 from this first row, and then the height of 3 looking at it from this way. Where those meet is the stack of 3. So here I have 3, 3, and 2. Here I have 1, 2, and 3. So this 3 and this 3 tells me that back corner has to be 3. The next one is also 3. Well, if I put the 3 here in either of these two spots, then I would have 3 in one of these two spots here, but I don't. So that 3 has to be next to the other 3. Then here, I only have a stack of 2. And I cannot have any more than 2 here. So that could be 2. Could it be 1? I don't know. That's a possibility. Maybe I'll erase that and we'll just put our options. Kind of like the Sudoku, if you ever play a Sudoku puzzle, we have options here. So we could have 1 or 2 cubes. So let's further explore. So from the right, we know this has a maximum of 1 block. Okay. Also, we have these 4 that are empty. So we cannot have anything in these 4 boxes. So that tells me that I have 1 block here in that front corner, because from this perspective, I can only have a maximum of 1. From this perspective, I have a maximum of 2. Okay. Now, this front corner, could it be 1? I don't know. Let's look right here. From here, I need 2 blocks. I don't have anything here. I don't have anything here. So that does need to be a 2. So now we've got our map plan filled in. Let's count the number of blocks for our volume. So 3 plus 3 plus 2, so 6, 8, 9, 10, 11 blocks. Okay. That is our three-dimensional 2D, 3D representations. So now let's explore our similarity theorems. We have a solid over here with a surface area of 32 square meters. So our surface area equals 32. Our volume equals 35. If I enlarge by a scale factor of 1.25, what is the new surface area and volume? So if that is my linear scale factor, that tells me my R is 1.25. What's my R squared? Well, 1.25 squared. Hold on, it's loading. 1.25 squared is 1.5625. 1.5625. Well, how about my R cubed, because I need that to do the volume. So let's take that 1.25 and raise it to the third power. Woo-wee, 1.953125. 953125. Okay, 1.953125. Yep. So my new surface area, we're going from smaller to bigger. So I am going to take that 32 and multiply by 1.5265. For my volume, I'm going to take the 35 and multiply by the 1.953125. I'll let you do those calculations and write down those answers. Let's take a look at this one. Here we have the surface area of a small shape and the surface area of a similar larger shape. So we are going to find R squared by comparing the two areas, the two surface areas. So 198 divided by 22 gives me 9.
Okay, Xander.
Okay. So this tells me R squared equals 9. Well, if R squared is 9, what's R?
Yeah, we can try to find
So we're going to take the square root of both sides.
Yeah, but
Sorry,
we
my
have to
children
get
are
12
playing
first.
Minecraft.
Yeah, I only have one.
Hey, boys, I'm trying to record a video.
Okay.
Okay, yes. So R equals 3. That is my zoom factor. Well, now let's consider volume. For volume, I need my R cubed. So I am going to do 3 cubed. 3 times 3 times 3 is 27. So if the volume of my first shape is 30, the volume of my larger shape is going to be 27 times 30. So that is going to give me, hold on, let me do some mental math, 810 cubic centimeters.
Xander,
Oops, cubic.
you have to wait.
Okay.
Ask Mommy.
The next part of our review is talking about surface area and volume. Remember our primary formulas for this, for surface area, is the perimeter of our base times the height of our 3D shape plus the area of two bases. Our volume is the area of the base times the height. So what I am going to do in this shape is declare that this here is my base. And so this is an 8 by 5 rectangle. There's my 5. So the area of my base is 8 times 5, or 40. The perimeter of my base is 8 plus 8 plus 5 plus 5, which is 26. So here, for my surface area, we're going to do 26 times my height of 8 plus 2 times the area of my base, which is 40. So 26 times 8 plus 2 times 40. So we have 208 plus 80, and when I add those together, I get 288 square feet. Remember, surface area is square feet. So now my volume, I'm going to do the area of my base, which is 40, times the height of 8 equals 320 cubic feet. For the cylinder, it's the same process. Just with our cylinder, remember, the base is a circle.
Oh.
So our base is the radius squared times pi, and the perimeter becomes the circumference, which is twice the radius times pi. Okay? Here our radius is 8, so we get 64 pi and 16 pi. So when we go to create the surface area, instead of using a rectangle base, we have that circle base of 16 pi. So I have 16 pi times our height of 9 plus 2 times the area of our base, which is 64 pi. So 16 times 9 is 144 pi. Don't forget that pi symbol. And then 64 times 2 times pi is 128 pi. So I'm going to add the 144 and the 128 because pi, think of it like a variable. These are like terms. So this gives me 272 pi feet squared, or square feet. That's our surface area. Our volume is going to be the area of our base times the height of 9. So 64 pi times 9. 64 times 9 is 576 pi, and that is in cubic feet. So that's our volume. So there really is no difference between the prism and the cylinder. The only difference is how we calculate the perimeter of a circle versus a rectangle. Let's take a look at the last page. Here we have a prism that has a triangular base. So here, the area of my base, so the base on this figure is that triangle. So the area of my base is going to be the base times the height divided by 2. And notice I use a capital B for the area of the base and a lowercase b for this base edge of that triangle. And that base edge is 9. So 9 times our height here of 2, because this is the height of the triangle. Okay, and then divide by 2, and that gives me 9 square miles. So my surface area is that perimeter of the triangle, which is 9 plus 3 plus 7, so 19 miles. So the perimeter times the height plus twice the base area. So we have 19 times the prism height of 2 plus 2 times the area of my base. So that's 38 plus 18, and that gives me 56 square miles. Our volume is the area of the base times the height of the prism. Well, the area of the base is the same. It's 9, and then the height of the prism is 2. So that's going to be 18 cubic miles. That's a pretty big shape. Same thing here for number 2, except this time the base is the circle. So our area of the base is going to be pi times the radius squared, and the perimeter of our base is going to be twice the radius times pi, or the diameter times pi. Here, my diameter, I believe that is 18, which means my radius is half that, or 9. So here, 9 squared is 81. So 81 pi for the area of my base. And our circumference is 18 pi. So the surface area is going to be that circumference times the height plus 2 times the area of the base. So we have 18 pi times 7 plus 2 times 81 pi. So 7 times 18. 7 times 18 is 126 pi. And then 2 times 81 is 162 pi. So now we are going to add these together, and we get 288 pi square miles. Our volume is the area of the base times the height, which is 7. So 81 pi times 7. So 81 times 7 is 567 pi cubic miles. Okay? And you are going to do the same thing for these two here. These are both prisms. This one, remember, your base is the triangle. So when you find the area of the triangle, remember, use those perpendiculars, your 3 and your 4, multiply, divide by 2.